Can you guess what the top 3 collection classes are in Java? Now, whether you can or can't, today's episode's for you because we'll get to know all 3. Coming up.
Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer.
Now, just before we get started, if it turns out you're completely new to Java and you haven't yet grabbed your Java Beginner Starter Kit, just go over to our website at javaeasily.com and go grab it there. It's a super helpful guide. It's going to get you up and running really quickly with Java. It's completely free, and it's just a really good resource for absolute beginners to get started with Java programming. Anyway, now into the content of the episode. So, this episode we're going to talk about the 3 main collection classes we've got in Java. Okay, it's an episode which in general is kind of for beginners. The reason being is because if you're a non-beginner, then you'll have come across these classes before. I'm sure you can guess which ones they are, in fact. Most people will have seen them before. But I think it's good to have a review anyway. And, it's always good to have a bit of a recap. And we're going to explain their properties and give some examples as well. And it's nice to just have that kind of bit of a recap to our knowledge, I think. Okay, so the first one is probably obvious. You've guessed it, and it's list. The list class in Java is used very commonly. Maybe it's, probably the most used one, I would say, a list, certainly for beginners. But just in general, it's used a lot. Now, the properties of a list are that its purpose mainly is to maintain an order of elements, so an ordering of the elements that are stored inside that collection. That means that if we store 3 elements, A, B, and C, then we have those elements stored in the order that they were inserted in, and that order never changes inside the list. So that's the first thing. Its purpose is to maintain an ordering. And also with lists, you can have duplicates. And the reason we refer to duplicates now, kind of almost out of the blue if you're hearing about lists for the first time, is that this is in stark contrast to the other collection class we're going to mention next, which is concerned with whether we have duplicates or not. And again, if you're a non-beginner in Java, you can probably guess which collection class that is. But yeah, so list, it can have duplicates, so that's not a problem, but its main purpose is to maintain an ordering of elements. The next question is, in which case, how is the order maintained? Well, the order is maintained really with 2 aspects, with the aspects depending upon the implementation class that you use. So list is an interface, right? So in the java.util package, we have the list interface, so java.util.list, and we have 2 implementations of that list interface. We have linked list and we have array list, okay? An array list is actually backed by an array itself. So this means, for example, if we have an array list of string, then behind the scenes, it's actually an array which is going to hold these strings, which is backing that collection. When we say backing that collection, what we mean is we're just saying that it's the thing really secretly that's kind of, the meat in the pie, as it were, or the good stuff inside the class itself. It's the thing that's really doing the work. The thing that's really doing the work is an array inside and internal to the array list itself. And by its very nature, an array maintains an ordering of elements because that's what an array does. It's just a contiguous block of memory where you have kind of cells or individual places where you can put items inside the array. And by its very nature, it's ordered because an array is indexed from 0 to the length of the array, -1. And yeah, we can't, shuffle elements around inside the array, at least not without explicitly doing that with like a shuffle method or what have you. So by its nature, an array is ordered. And so therefore an array list, which wraps that array, or rather which presents that array to the outside world, in terms of this list interface, it's also ordered as well. Okay, so for the array list to be ordered, that's quite obvious. That's how that's ordered. It's backed by an array. A linked list, maybe that's not so obvious, but a linked list behind the scenes, the reason it's called a linked list is because how it stores the data, it doesn't have an array inside. What it does is it basically defines kind of like a cell or a node, you could call it, class inside the linked list implementation itself. And that node class basically has a variable inside it called next element or next or something like that. And effectively what that next element does is it holds a reference to another node element, which is the next element along. So if you can imagine a linked list, you start out with, when you insert something into it, 1 element. So that means now we've got 1 instance of the node class holding the value of whatever it is, okay? And then when we call add again to add our second element, behind the scenes, the linked list then creates a new node instance, and it sets on this one the value of the next variable to point to this new node. So now we have an ordering between the first node we had and the second node we had. And Again, once you add another node, again, it does the same thing. It creates a new node. Sorry, once you add another element, rather, it does the same thing. It creates a new node, and it sets the next variable to point to this new node. And so because of this, we're kind of like daisy chaining these across, or like chaining these together, if you like. And that's how the ordering's maintained inside a linked list. So 2 list implementations, which are used all the time, and that's how they're implemented behind the scenes. So what might an example be of a list? If you want to have something which it can have duplicates, but its main purpose is to maintain an ordering of elements, what examples might we have? Well, one example could be people entering a raffle, for example. So when you enter a raffle, you can enter a raffle multiple times. So I might buy 3 tickets, for example, and 2 co-workers I've got might buy a ticket each, okay? And that's fine, because then we would have, for example, 3 instances of me inside this raffle, for example, and then we'd have the other instances, the 2 other instances of my co-workers. So 3 of me, 1 of co-worker 1, 1 of co-worker 2. So we'd have 5 elements inside the list, 3 of me, and then 2 of the co-workers. That's one example. So that's an example where we could, have duplicates, but we don't necessarily need an order, okay? Another example could be submitting jobs to a particular processor. For example, a print queue. When you submit a job to a print queue, you can have duplicates, right? So I could, for example, choose to print the same page of a Word document twice by going to a specific page in a Word document and doing Command P, submitting that to the print queue, and doing Command P again, submitting that to the print queue. If this was implemented in Java, this print queue mechanism, then that's okay because we've got duplicates and a list will tolerate duplicates. But the thing we're really getting there, what we're really getting out of the list, is the fact that we need to have an order, because obviously the first person to submit a print job is the first printout we need to have. In other words, it's a first come, first served type scenario. So from that point of view, we definitely want to have a print queue holding this ordering of the order that people submitted jobs to. Okay, so that's 2 examples really for list. So that brings us to number 2. Number 2 would be a set. So a set, basically, the idea behind a set is that we don't have any duplicates. And its purpose is to maintain unique elements through the fact that we have no duplicates. So that means that if we had, for example, a set of employees, we'd only ever be able to have 1 of me and 1 of coworker 1 and 1 of coworker 2. We wouldn't be able to, for example, have 3 of me and then 1 of each of those like we did before in the list example. We can't do that because a set doesn't tolerate duplicates. Now with a set, we don't have any order. That is, we don't have any guaranteed order when we get elements back out from the set. So for example, when we're traversing a set, when we're iterating over a set's elements, we don't have any order. There's a way around this. If you're more advanced in Java, you can use something called a linked hash set. And what that actually does behind the scenes is it's still a set, it's still implemented as a set, but what it does is it maintains what's known as insertion order. So when we insert an element into the set with like, my set.add A, my set.add B, my set.add C, whatever it might be, when we are inserting into the set, what actually happens behind the scenes is it's kind of using the idea we expressed before, with the linked list, where it actually uses that kind of structure behind the scenes to put links between the elements that are added. So in doing this, it can maintain the order the elements were inserted in. And then when we get them back out, when we traverse over them, we can get them back out in the same order that they were inserted in. But that's, in general, something that we don't use as beginners, but it's a more advanced use case. But it's useful if you want to have, for example, kind of like a list which doesn't accept duplicates. So you could kind of use a linked hash set in that case. Now, how is this no duplicates thing actually done? In other words, how is it that when we call add on a set, that it somehow rejects a duplicate element? In other words, if we try to add me as an employee, and we've already got me as an employee inside the collection, how does it know to reject me? Or rather, how does it know to reject that second instance, which is logically equivalent to the one which is already held inside the set? How it does that is with the famous equals and hashcode methods. So in a nutshell, what it'll do is it'll do an equals check, conceptually speaking, whenever you try and insert an element. So when you try and insert a new instance of me into that collection, into that set, it'll check, conceptually at least, all of the different elements to see if they're equal to this instance that I'm trying to put into the set. But it's a bit more complex than that, because what actually happens is it doesn't need to check every single instance. What it needs to do is it needs to look in the so-called matching hash bucket for that particular instance. And this is where the hashcode method comes in. So in a nutshell, an object has a hashcode, right, which you define the logic of when you override equals and you override hashcode. It has a hashcode, which is just a number, right? And then there are 16 linked lists, effectively, behind the scenes inside a hash set. Hash set, by the way, is the implementation of set we're considering here. So again, set is an interface just like list was an interface inside the Java.util package, and it has the implementation hash set, which is what we're talking about now. So when you go to add inside this hash set, it'll basically say, okay, I'm adding, employee Matt, okay, and it basically will say, okay, well, what's the hash code for Matt? The hash code is 32,748, for example. It'll then do a little trick, which effectively, it basically divides it by 16 and finds the remainder of a division by 16. And that number, that gives you a number then, which is basically between 0 and 15, okay? And then if you imagine you've got 16 linked lists behind the scenes, let's say that number is 13. So when you divide 32,768 or whatever, I realize that's a special number in Java, forget about that, or in computer science in general, but whatever the number is, when you divide it by 16, and I don't know what that is off the top of my head, imagine the remainder is 13, right? Which it wouldn't be for that particular number, but forget about that for now, because it's a special number. But if you imagine that when you divide it by 16, it gives you 13 as a remainder, then it would go inside the bucket, that is the linked list, with index 13. So it'd look in basically the 14th linked list along. So it wouldn't be the first linked list at position 0, wouldn't be the second linked list at position 1, wouldn't be the third linked list at position 2. It'd be, the 14th linked list at position 13. And then it would look inside this linked list. And we said a linked list is like, basically a string of elements which are kind of chained together. And it would then call the equals operation on each of these elements against the element that you're trying to add into the list. And if it found a match, in other words, the element was equal, so the element I'm trying to put into the hash set is equal to one that's already stored in that particular hash bucket, then it would reject it and it wouldn't allow it. Because otherwise that would be a duplicate entry. This is why, by the way, it's incredibly important, and I appreciate now it's gone from a beginner's episode to something pretty advanced, or at least, above intermediate level in terms of concepts. But this is why it's very important that whenever you override equals, you also override hash code. We're going to talk about that in a different episode at some point in the future, but it's just something to bear in mind. But that's ultimately how a hash set can, restrict duplicates being added to the set itself. Now, if it exists already inside the collection, no biggie. It's not going to throw an exception or anything. It's just going to return false because it couldn't modify the collection. And if it could insert into the collection, then it will return true back out. So that's the semantics of the return value, which comes back from the add method when you're adding an element into a thing like a hash set. So an example here of a set, for example, this time we gave 2 examples before of lists. An example here of a set might be employees in a payroll run. We don't want to have the same employee multiple times in a list of employees which we need to process to, make a payment of their salary for. If I'm in the employee set twice, then that means that I can get paid twice. Although thinking about it, that's not a bad idea. But anyway, we wouldn't want to do that in a production application, obviously, for obvious reasons. And that's one of the key things about working with the collections classes and looking at the collections API. It's basically picking out the correct collection, or the most fitting collection that you can use, or that springs to mind rather, for a specific task. And then therefore that's, what enables you to do that, or to find that out, or to figure that out, is knowing about these different properties of the different collection classes, or so-called abstract data types that we have in the collections API, which is why we're doing this kind of episode. So you've got those kind of front of mind when you're dealing with and programming with the collection classes. Now, the final one we come on to now is the map class. Okay, so the purpose of a map is basically to hold a mapping, right? And that's where we're mapping one thing to another thing, okay? So it's where we're maintaining kind of like an association between 2 sets of things. When I say sets of things, I don't literally mean sets like we've just looked at before, but I mean, conceptually speaking, we're mapping one thing to one other thing. Okay, we'll give an example in a second. But yeah, the purpose of a map is to hold a mapping, okay? One thing being mapped onto another. And for this case, we can have duplicates of values, okay? So one thing can map onto another thing, and another thing could map onto the same thing. That's no problem. But we can't have duplicates in the keys, right? So how maps are constructed is we have keys pointing to values. Okay, so it's the key which is mapped to a specific value, and we can certainly have, like, if we look at the values set, or the set of values, right, inside that map, we can have duplicates in there. That's fine, right, because many things can map onto the same thing, but we can never have duplicates in the keys section because that would lead to strange situations, basically. So in general, with maps, they're used for looking things up. So you pass a key in and you get an object back out if it's stored under that specific key. So an example will make this clear. So we could have, for example, an English to Spanish dictionary, and we could implement that as a map, right? So inside this English to Spanish dictionary, on the one side, which is the keys side, right, we'd have the English words because it's English to Spanish, right? So the mapping is English word in and then Spanish word out, right? Okay, so English words like, for example, man, brother, house, for example. So man, brother, house would be the keys inside this particular map in this not a very useful dictionary because it's only got 3 words. So we'd have those, and then we'd have the corresponding Spanish then as the value set, where each Spanish word would correspond to the corresponding English word. So man as an English word would map to hombre as a Spanish word. What else did I say? I said brother. So brother, for example, would map to hermano in Spanish, and house would map to casa in Spanish or whatever. I was actually testing my limited Spanish at the same time, so apologies for any pronunciation for people who can actually speak Spanish. But that's the idea. We've got an English to Spanish dictionary and we do that as a map. Now notice it's one way. In other words, we give the English as a key, right? And we get the Spanish word back out as a value, right? It's one way because we can't give the Spanish and get the English back out. So a map intrinsically is one way in the JDK, in the Java Development Kit. It's one way is hash map, which is our implementation. Again, we start by referencing the interface. So java.util.map is the interface, just like we had java.util.list and java.util.set in the previous 2 collection class scenarios. So yeah, java.util.map is the interface, and it's java.util.hashmap, which is the implementation of that interface. But in the JDK, hashmap is one way, right? So it's not bi-directional, it's only unidirectional. We can have bi-directional maps, by the way, if we use and turn to other libraries, but these are outside the JDK. So for example, in Guava, which is used to be Google Collections, or I think whatever it was called, in Guava, the Collections API from Google, and there's a hash bi map, which is a bi-directional map. And also in Apache Commons Collections, there's a dual hash bi-di map, which is again a bi-directional map. But in general, in Java, we don't have that facility, it's just unidirectional. So if you wanted to have the Spanish to English, then you would have to have a second map inside your application. So you'd have one map for English to Spanish and another map for Spanish to English. But then also, of course, be careful that you respect whether you can have duplicates or not. So just to be aware of that. Or better still, just use one of those libraries we've said, so Guava or Commons Collections. Right, so a lot to take in there. Now, in a future episode, we'll dive in further, because there's more to learn. But today, we covered a reasonable amount of ground on the basics though, so hopefully that was good, and you got a lot from this episode. Anyway, that about wraps it up for now, for this episode. All that remains to say is thanks for listening, I hope that was helpful, and have a great day ahead.